Now let's practice factoring by grouping. Let's look at this example first. If I look at my first two terms, I want to find anything that they have in common, so any common factor between the two. Well, I notice an x squared in both of them, and I also notice that 3 and negative 12 have a common factor of 3. So that means I should be able to pull out a 3x squared. Here that'll give me an x. Here this will give me a negative 4. And if I want to make sure I did this correctly, I can always distribute, and I should end up right back where I started. So 3x squared times x will indeed give me this. 3x squared times negative 4 will indeed give me that. So we're in good shape. We know we did this correctly. Now, if I want to look at these two terms and find out what their common factor is, I actually can't find one besides 1. 1 is the only thing that will go into both of those terms. So I can pull out a 1, and notice that these two factors do match. That was my goal for factoring by grouping, because I want to be able to pull those out. So when I do pull these out, I end up with 3x squared plus 1 times x minus 4. So I'm done. This is actually how I would factor this by grouping, and I can stop here. So if I wanted to check, make sure that I got the right thing, I would just distribute this to each term, and I'd end up back here. Then I could distribute this to these terms and this to these terms, and I should end up back there. So we can always double check that we've factored by grouping correctly. Let's look at this second example. So our first two terms, the only thing I see in common between those two is an x squared. So I can pull that x squared out, I end up with negative x plus 2. Then if I look at the last two terms, what I see between those, the common factor between those, is 4. But then I get x minus 2 as this factor, and negative x plus 2 here. Well, what would happen if I actually pulled a negative 1 out of this? Well, it would have to change the sign of each of the pieces inside, right? Because I want this to be 4x. So in order to get negative 4x times negative x to be 4x, this needed to change sign. Same thing here. I wanted negative 8x, so if this is negative 4, I need a positive 2. So I pulled out that negative, and now I see that I have what I want. These two terms actually do match. So I can factor by grouping. I can pull this out. So I get x squared minus 4 times minus x plus 2. However, I'm done factoring by grouping now. This would be fine to leave it like this. But I notice that this is a difference of 2 squares. That's really easy to factor. So we might as well just factor this all the way down to its linear factors, just for practice. And there we go. We factored it all the way down to linear form. Well, linear factors. Okay, let's look at this third example. So my first two terms, I see that I have x squared in common, and that's it. So I have a minus x plus 6. If I look at my second two terms, it looks like I have a 2 in common. So I get 2 times x plus 6. Now, notice with these that these do not match. And even if I pull the negative 1 out here, this sign will change, and so will that sign. So no matter what we do, these two factors never match. So these are not the same, and thus we can't factor this by grouping. There's just no way to do it. So we need to be careful with that, make sure we're being really precise with our signs. So that one we can't do. Let's look at this one. So if I look at my first two terms, I would say I have an x squared I can pull out, I have a 2 I can pull out, and I also have a negative 1 I can pull out. So let's pull out a negative 2x squared. So here I'll have a 2x, and here I'll have a plus 3, right? Because if I multiply these, I get that. If I multiply these, I get that. So I'm good. Now, here I see a 4 as our common factor. Because 4 goes into 8 twice, and 12 3 times. So thankfully, these do match, so we can finish factoring by grouping. So we're going to pull that out, and it will look like that. Now let's look at this example. My only common factor I see here is an x squared, so I get x minus 1 when I pull that out. Here, the common factor I see is a 3 between these two factors. So I get negative x plus 1 when I pull out that 3. Now again, notice these aren't exactly the same, but if I pull out an extra negative 1 here, that sign will change, this sign will change. Now we have the same factor, so now we can factor by grouping. There we go. Let's look at this last example. So if I look at my first two terms, I definitely have an x squared I can pull out of both. But I'm going to argue that 1/2 divides into 4 evenly, right? So I can pull that out too. So here I'll just end up with an x from this term. From this term, I need something that when I multiply back through by 1/2, I'm going to get 4. So I actually need an 8 here. Because then if I multiply back, if I distribute, I get 1/2 x cubed, and then 1/2 times 8 will give me my 4 times my x squared. So I actually need an 8 here. If I look at these two terms, my common factor is a 2. And these two factors match. So we can pull them out, and indeed we can factor this by grouping.